Hello everyone, welcome to this third eRum profile. I'm here with Federico. Hi Federico.
Hi.
And I'm here with Tomas Kalibera.
Hi.
Hi Tomas, how are you?
Hi, I'm good, thanks.
Great.
Yeah.
So Tomas is a researcher at the Czech Technical University in Prague. He's a member of the R Foundation and an active R core developer. And of course, he's one of the eRum 2020 keynote speakers for the virtual conference in June. So welcome to everyone, and welcome to you, Tomas. Okay, so let's start this R chat. I would start with, let's say, from what I understand, you deal every day with nuts and bolts of R working mechanisms, which is pretty interesting to me. But you basically operates under the curtains. Would you share with us what is about and working under the hood of R and your experience?
Yeah, sure. Like the best situation is when the users don't notice, right? When things can get faster or just keep working with newer system, with new libraries, with new operating system without noticing anything. But it's the ideal case that doesn't happen all the time, of course. So a lot of my work is driven by bug reports, right? It's usually after a release, like this time, we are soon after the release of R 4.0. So there are bug reports about things that people have found that don't work so well. And we have to fix them. And I always feel this strange pain in my neck when I realize while reading the bug report that actually I broke it, and of course then I go to fix it, but oftentimes I go to fix it even when I haven't. So a lot of it is driven by bug reports, and then of course by also the urgency to improve things, not just to keep fixing what is broken. So when there is time, we want to do something bigger, of course. Now it is, for instance, I have been playing with UTF-8 support on Windows. It's a big pain for a lot of Windows users. It's the irony that our core doesn't use Windows. We just all use Linux or Mac, but a lot of users of R use Windows, and on Windows they cannot in R set UTF-8 as the native encoding, so they get a lot of problems when they use Chinese characters, for instance, on Windows that are in Europe or United States, and we would like to fix this, and now it is possible. Earlier it wasn't. Now the Windows finally allow this, but it will be a lot of work, and I have been experimenting with how to do it recently, so they are some of the bigger things that can change also, not just fixing bugs that have been there from the beginning or that we have introduced recently.
So basically, we have just probably faced one of the biggest potentially breaking changes that we could have had in the whole R history. So strings factors now defaults as false. So who called the shot?
Mostly this was Kurt Hornig. Like, he has done most of the work. He has also written a short blog post. Maybe you have read it on our R developer blog. Yeah. So he has been like, he had the energy to do the change and most of the thinking and discussions. But there was a lot of discussions on R core about this for, I think, for years, actually. I would not be surprised if it started before I joined. But I have been around, of course, when it was during the last year. In Toulouse at USAR, we spent a lot of time locked in a room, actually skipping even some talks. Sometimes we were sorry for skipping that, but discussing things like stringless factors. So Peter Dalgaard was contributing a lot to the discussion, of course. It's very hard to change things that are so visible as strings as factors. And now it seems that the decision in the past for the default was wrong, of course. But and there is an agreement on it, but changing it is so hard. And I don't understand all the details. It's mostly for the statisticians, which I'm not. But one part that I do understand well is it's hard to sort strings, right? Like the computer science part of the problem is that there is not a single reproducible way to order strings lexicographically, because it depends on the locale, right? And now you have, if you end up using ordered factors that are ordered by some arbitrary order that is depending on the locale, you will always have some problem. And just the question is when you capture this. So we spent so much time discussing how to define or where to find some universal sort order. And at the end of hours of discussions and coursework and so on, there is just a small change of code, and a lot of breakage for people. I hope in the end useful. But yeah.
But it's I don't know. I think it's for the best. I've been burned a lot of times by not knowing that strings as factor was default to true back then, and of course, say once you start as a newbie, it's something that you probably do not know, because it's probably not the most, how should I say, the most natural behavior if you do not know that your string will be encoded as factors. But okay, can you anticipate what the next big thing could be in the development of R?
Well, the question is, okay, so this one looks big because it is breaking a lot of things and it's very visible, right? But I think there were actually bigger changes already, right? And that's getting to the question, like this R 4.0, it has reference counting. It was not done by me either. It was done by Luke Tierney, but he has been working on that for many years. And ideally, the users would not notice, and I think they haven't. Like, he usually gets the things right. And then, so it's changing the way that the sharing of object is tracked internally in R a little bit. Like before, we had this named mechanism, which was also sort of reference counting, like counting the number of names for a variable, but it couldn't go down in the previous implementation. And in this new, it can go down, and this means that in the future there can be performance improvements of function calls, because when a function is called and then it returns, we will more often know that the environment of the function is no longer needed, and we could just throw it away and save memory. And we could ideally implement in some cases the environment on the stack, as it is done in other programming languages, and it would be then much faster. So there are potential big speed ups that will be possible, hopefully, with this change. That is
much. We would not even notice that.
Yes, and that was much more work than this one. Like, so it's a question: what is a big change, right? But okay, if this UTF-8 on Windows will work, that would be a big change for Windows users, and it's actually something that doesn't require a change in the code of R. I have done the change that was needed, but it was very tiny. The big thing is that we will need a new Windows toolchain. Another new, right? This R 4.0 has a new Windows toolchain, yeah. R24, but it's not new enough to support UTF-8 on Windows. So we would need a complete new toolchain that will be incompatible with the old one. So with this one, you can sometimes use code that has been compiled by the previous toolchain, forgotten in some libraries or something, but with the new one, you would not be able to. So it would be maybe a big change, I guess. And yeah, and for the other things, it's hard to say, because like most of us are volunteers, and like I have the like great, I'm in a great position that I can work on R full time, but still my work is driven by bugs a lot. So I can't predict how much I will be able to do in what time. So usually we don't know in advance what will be the biggest change before we just can do it. Also, it's hard to predict the time that you need for debugging. when I started this in Arcor, I helped Luke Tierney with the bytecode compiler, and it was a very big change a few years ago. And again, he worked on it very many years, and it was finished, but almost complete. Few bugs, but very few. But a lot of packages were breaking with it, just didn't work with it. And I spent several months debugging the packages to find out if it's a bug in the package or if it's a bug in R. Oftentimes it would be both, well, or it would be it can be a woken up bug. It's a common thing, and probably you know it too from application level programming, that by changing something, your program starts breaking. But it's not because you would have your change would have been incorrect, but because there is some other bug in the program that has been there before, but it didn't matter before, and you just make it matter by making an innocuous change. And these are very hard to find. Yeah. So with some of these bigger changes, it's hard to predict when we will be able to finish them, because it may be months of debugging packages. That's
probably you want to throw out a big shout out to people that use properly unit testing in their packages and
yeah,
make these things probably easier to detect.
I think that yeah, a lot of people write tests. The coverage could be much better, but it's cheap to say. Of course, I think that people know they should write tests. I think what is also important is being responsible when choosing the technologies when you develop your packages, because it's not just about being able to write it once and have fun, but it's about being able to maintain it, and also to make it relatively easy for others to debug your code, because sometimes it happens. Like our core people we are using the packages as a test suite for us, right? Our core. So in addition to the regression tests that we have anyway in R, but CRAN and Bioconductor, all of them are our test suite. So if I change something in the bytecode compiler or anywhere else, I will run all of CRAN and Bioconductor packages and have a look which are failing and which have been failing before my change. So whether I have probably broken any of them. And then I have to go and debug all the cases and find out why, right? And yeah, it can be this woken up bugs, but it can be by bug, and oftentimes it is, and so on. And so easier it is to debug the packages, then this is less work to do. If a package is using native code, it's much easier to introduce bugs, like these protect bugs, right? If it is not using native code, but just R, it's usually easier to debug, and yeah, and so on. And then it depends on how defensively it is programmed in the native code, and so on. So we like writing the code that is as simple as possible for the task is always helpful. And as all the programming people say, premature optimization is really a bad thing, right?
I'm pretty scared about the definition of bug-driven work or bug-driven job, actually. And so I'm so happy when I find stability in my little system, allowing me to make an analysis and take it to the end. So when I have to change something, I say, oh my God.
Yeah, we are pushing the things a little bit to the limits, right? It's like the police who sees all the criminals, right? So Luke told me once that he didn't trust the package X that I wouldn't name, because he believes that he can make it crash by normal legal use within a minute or something, and he tried and he was able to, right? And normal users usually don't run into that so easily. Like when we know how the things work internally, it's easier for us to sometimes to trigger the faults and to see them, and by fixing those, hopefully we are reducing also the chances that real users will run into many of these problems. But sometimes, of course, it happens.
possible.
Yes. The CRUN team is doing a lot of work of trying to enforce some rules and improve the quality of packages. And it is not so widely known, probably, that also the CRUN team is debugging the packages a lot. It oftentimes the authors of the packages don't have time or don't have the skill when they use just low-level technologies to debug the packages. And also some of the senior members of the CRUN team, they have so much experience that they can find the bugs relatively easily, but it means maybe hours, right? Or sometimes, but I'm not so experienced, of course, but sometimes it takes me days, right? It's not unusual to keep looking for a bug in package or in R. You never know at the beginning where the package is, of course. It's also why it is harder to tell the package authors to fix it. Because when you see package X to fail its test, it doesn't have to be a bug in package X. It can be a bug somewhere else, right? And would you just motivate the author to spend 3 days debugging on his own or her own, and then find out it's not their fault, right? So it's another reason why the CRUN team is helping a lot in this way, and I'm not sure if it's widely.
And as a constant reminder, they're doing it basically in their free time.
Yeah, well, yes, some of them are retired, so that's completely free time. Some of them are professors, and like their departments are appreciating their work, of course, but cannot like directly make it as the main part of their job, right? Usually the departments where these people work at the universities are supportive, of course, otherwise it would not be possible.
So I was wondering, how many bugs did you see? So when did you get started in R?
Yeah, well, I started as a user, right? And it's a long time ago, of course. So in 1999, I was looking before the interview at the dates I not remember. Otherwise, I started taking a stats course at the university, and we were learning statistics and examples how to use it in S+, right? And in 2000, we took some labs where we had to do the assignments in S+ or R, and some of us used R because it was free, and so we could use it legally from home, and it was better. And then I think 2003, when I started my PhD, I started using R a lot for analyzing results of benchmarks. I'm a computer scientist, and for my PhD I was doing benchmarking. So methodology how to measure performance of software, and you generate a lot of data, and then you need to create graphs, and I wanted to do some statistics gradually. So I started programming in R in 2003, and I use it a lot. I wrote relatively big programs, not like transposing data and plotting graphs, running tests using packages like others too, of course. And then in, I think, 2012, I started implementing R. It was a big change, but at the beginning it was a project. It was trying to implement a new version of R, like an experiment that would be faster in Java. Maybe I should give some background. Like before that, I did 2 postdocs in programming language implementation, where I was working on garbage collection on real-time Java. So on implementation of Java, essentially. So the internals of a virtual machine, compilation, sometimes bytecode interpretation, and garbage collection, and these things, right? And then with this experience, I was asked to implement R in Java, and so we were trying to make R much faster than it is. And we had a set of benchmarks on which this toy implementation worked, and we could get speed ups about 5x on these benchmarks in Java. The project later continued and was rewritten and so on. But I spent about 2 years roughly on that. And during that time, I was already interacting with Luke Tierney from the R-Core team, because he was interested also in learning if he can find out anything useful and if he could use it in the real R, not in this toy. And he has taken some of these things. He of course gave some ideas to us also, and I started interacting with him more and more, sending suggestions and bug reports like privately. And then when this project ended, I came to the conclusion that it's not so useful to try to re-implement R from scratch, because it's not realistic at all that we will become compatible with R to the point that all packages will work. It's just impossible. And also, at least the way I was writing it in Java, even though it was giving speedups that would be very nice to have, it was not scaling so well. The speedups were based on specialization. So like when you add two vectors, for instance, instead of writing, I don't know, 20 lines of code, I had 500 specialized for different cases. And so this would hardly scale to the full R implementation. Also, personally, I didn't find it very useful to use Java for that. The idea behind the project had some sense, of course, because there is so much energy that has been invested into Java development. Some people say hundreds of many years, right? Which is something we can't dream of just for the interpretation of R. So yeah, but it's hard to reuse it, and it seemed very unnatural to me to do numerical computation in Java when everyone does it in Fortran and C library, math library, and so. Okay, so eventually I kept saying that we should do it in real R, and I was extremely lucky that Jan Vitek, with whom I was working, just found the grants and made it possible. So I started experimenting with the real R implementation, like R that everyone uses, and first trying to implement some of the speedups that were working in the Java version for real. And then I started working even more closely with Luke, and then giving some of the feedback. And eventually I realized that some of my changes were still too big, that it would be very hard to make all the packages work with them. So I gradually started making smaller and smaller changes, but at the same time they probably became more useful. So eventually Luke started adding my patches to R, and yeah, and finally I ended up in R-Core.
Project? Was that the ranging project?
No, it was a fast R project.
Okay.
With Oracle. So at the beginning we get some support from Oracle, and it was a collaboration with Oracle Labs. Now they have also a faster project that is doing the same thing, but they have rewritten the code. They are, as far as I know, they are not using my code anymore. They have their own system that should allow to implement interpreter of any programming language. The idea is that you write a relatively naive implementation of your language in Java, and this almost magic system will turn it into a very fast implementation. So it's an Oracle project. Yeah. We were just collaborating with them at the beginning on the part that was addressing R. They try to address other languages as well.
So from your point of view, which is, I have to admit, peculiar, probably it's rare, at least for me, is it correct to say that R evolved toward, let's say, from a data analysis tool? I mean, it's a data analysis tools, of course, but toward a programming language, or to what extent? Because I know that there's a bit of discussion, you know, R is not a programming language. But from your point of view, what are your thoughts about it?
Yeah, it's hard to say, because I have been in close contact with people from Arcor only for a few years, right? Last few years. If it would be much better, of course, to ask some people who are there for the last 20 years, right? And even though I started using R so long ago, I was very isolated, and I have been using R as a programming language at the time, because I was a programmer, right? So initially I was doing the interactive data analysis with R, which it was probably meant for. But then very quickly I just started programming very large programs in R. So I don't know. It may be that people are programming more now than they were before. Maybe they care a little bit more about performance, and then if it seems slow, they very quickly, for us to quickly switch to C or C++. But yeah, I don't know that. I'm not aware of any statistics how much is R used for programming versus interactive data analysis.
I'm amazed by the work that that can be done, and actually that is done under the hood, because I have been using R for not that many years, but let's say probably 6-7 years. But I did see a lot of improvements. So I'm grateful to you, Tomas, and other people like you, dealing with garbage collections and memory efficient things.
Yeah, that's mostly Luke. Like the current garbage collector is written by Luke Tierney in the memory.
Yeah. Okay.
And it's
Fair.
working surprisingly well. It's a very simple implementation, and it works good enough. So we are able to keep using it for a long time.
Okay.
So you mentioned that, so basically all the Arcor members do work basically without Windows, or say with Linux or Macs. Can you tell us something more on say what and where and how your ideal workflow is? So we just heard from the pre-interview phase that you can and do work from home efficiently.
So I have a very nice network here. I renovated my apartment, so I have a network like a smaller company. And also the people I really collaborate with are from the Arcor, and they are not in Prague anyway. So of course, if I could sit in the same room with Luke or Kurt or Brian or Martin, that would be very useful, but it's not possible. Sometimes we meet actually with Luke. Sometimes he comes to Prague and we can work together. But otherwise, I'm just used to it. I was a postdoc for 4 years, and then it's also usually that you are locked in a lab and you just program, right? So you have to find some fun things to do in the evening so that you don't kill yourself. And it's I try to keep weekends for other things than working, and then somehow it's good.
Tomas, so if you would you like to just give us an appetizer of your keynote during the eRum 2020 in June? What are you going to talk about?
Well, I will. It's, to be honest, like I will pick some of the last things I have been working on that are impacting R. I can't tell what it will be because there is so many things in flux about user. So I'm committed to a number of talks, and obviously I will not give the same talk twice, right? So so it will be something about what I have been doing in the last year. It can be the encoding stuff on Windows. It can be something about speed ups in the parallel package. It could be something about debugging low level things to give people some idea what it takes to debug some bugs. It like intuitively, I think that you have to go one level lower when you are debugging, right? So oftentimes when you have a bug in R, you have to go to C to see what happened, right? And now, if you are programming in C, sometimes you have to go to the assembly, and that is what has happened to me, I think, already 3 times in the last half a year. Like the last few days, I was learning the assembly language for the power CPU. Well, so it might be amusing to tell people about some of these problems. Oftentimes, it is so that I spent 3 days doing some debugging of an assembly code, and then I file a bug report against the compiler, or I change one command line option for the build of R. So 20 characters change, and that's the result of those 3 days work. And also, of course, the result is that something is not crashing that has been crashing before. So I may choose some of these things, and the things that we usually write on the R blog. So it would be something technical and something that I have been doing. I don't like talking about things I don't understand. So it will not be strings as factors now. I'm sorry.
I'm just wondering how hard and how hard it is to keep up, say, the inner fire or the motivation for doing something that basically no one pays to access for, and many times have only demands, and sometimes are not even asking in a polite way. How do you keep up the commitment in open source development?
Well, okay, so of course I don't do it for free, right? I am paid, right? Not by the users, but yeah. So, but of course one needs some internal motivation to do this. And for me, part of it is that I have been a user of R before, and so I liked it very much, and I found it very useful. And now I am in a position that is quite unique, that I can actually help, and like being useful makes me feel satisfied, right? And I have been doing research for a long time, and when doing research, it's harder to persuade yourself that you are doing something useful, even though the things are bigger, right? Like the things I have been doing in the garbage collector or something were intellectually more demanding slightly, and so on. But then there is a paper, and that's it, right? Usually. But with R, I see that people are using it. It's probably a few million people. You don't know exactly, but that was some estimate a few years ago, and even a relatively small change can improve it. So it's feeling useful, and also it's interesting work. It's ironically finding some of these hard bugs is actually more intellectually challenging than adding new features, even though of course I like adding new features a lot. It's sometimes you have to work a little bit also like a researcher, like you have to post some hypotheses, and then you do some experiments to find counterexamples and so on. And it's not just intuition, it's also like a little bit of science or fun, definitely fun. So it's a very interesting work, and it helps that it's useful. Also, the people in our core are extremely friendly, and it's very pleasant to be able to work with them. And many of the people who are sending bug reports are nice. Yeah, so it's not that everyone would be mean when they find a problem. But sometimes it happens.
It's a very nice point of view. I mean, I appreciate that. Thank you. That's great.
We are lucky to have people like you driving this project, and say we will be even luckier to have you as a speaker, as a keynote speaker at eRum 2020.
Yeah.
I think I leave it up to Rick for closing. Or do you, Tomas, have any questions regarding eRum?
Well, I'm of course curious what will happen, because I have never been on a virtual conference. So I don't know what will happen. I'm sure you will tell me in time. It's a very weird situation, because I'm sitting at my home and there may be a lot of people listening potentially. So it's a strange combination.
We will see together. We will see together how it's going on, and actually these interviews are part of the game. So we're already doing eRum 2020. That's why you see here. Oh, well, not here. Here, the logo, the virtual one. So Thank you very much, Tomas, for your words and for your time. And we appreciated a lot having you here for this.
Well, thank you.
And
thank you.
we're looking forward to hear your keynote speak in June. Thank you.
Thank you. Thank you very much for inviting me. It's a pleasure.
Bye-bye.
Okay. Bye-bye.
Thank you for your time.